Bismillahirrahmanirrahim. In this session, we will discuss the trigonometry and its fundamentals and basics of trigonometry. In a trigonometry, we actually discuss right angle triangle. In a right angle triangle, this longest side is called hypotenuse. The longest side is called hypotenuse. And side opposite to the angles are using called the opposite. So this if you consider this angle, then this becomes opposite, and the angle with the 90 degree is called adjacent. So this side is called adjacent, this is opposite, and this is hypotenuse. The hypotenuse is the longest side, and the side opposite to the considered angle is called opposite, and the angle and the side touching with the 90 degree is called adjacent. Similarly this one, so this, if we consider this angle, then this is adjacent, and the opposite of this angle is opposite. The angle is opposite, so this side is called opposite, the angle, this angle, and this is the longest side is called hypotenuse. For a given triangle angle delta theta, all right angle triangle with the angle theta will be similar, and it follows that the ratio of the sides will be constant for all values of theta. So the ratio opposite upon hypotenuse, this opposite upon hypotenuse is called the sine of the angle. So sine theta is equal to opposite upon hypotenuse. So sine theta is equal to opposite upon hypotenuse, while cosine is adjacent upon hypotenuse. So this is adjacent upon hypotenuse. So adjacent is this one, and the hypotenuse in the denominator. So adjacent upon hypotenuse cos theta, and the last one is the tangent is opposite upon adjacent. So this is opposite and divide by adjacent. Opposite upon adjacent is a tangent. So we will use these ratios, these three definitions, for our working. So exercise 36.6, in this diagram find the length marked A, B, C, D, E, F, G, H. So we have to find this A. So this and this sides are covered in sine theta. So sine theta is equal to opposite upon hypotenuse. So sine 30 degree is equal to A upon 7. So we have like this. So for one, this is sine 30 degree, this is angle, this is opposite divided by hypotenuse, opposite upon hypotenuse, so A upon 7. So A is equal to 7 into sine 30 is equal to, sine 30 is 0.5, so 7 into 0.5 is 3.5, and this is centimeters, so this is also in centimeters. The second problem, this is 65 and this is 16, this is B, and this is adjacent upon hypotenuse. So cos 65 is equal to B upon 16. So B is equal to 16 into 65, cos 65 degree. So on taking the cos 65 and multiply with this 16, we get 6.76 centimeter. For this problem, this is opposite because angle opposite. So sine 70 is equal to C upon 8.7. C upon 8.7 sine 70. So C is equal to 8.7 into sine 70 is equal to 8.18 centimeter. Similarly for this one and for this one, this is the angle, this is 4.1 centimeter, this is F, this is adjacent opposite. So tangent theta, tangent 18 degree is equal to F upon 4.1 centimeters. So tangent 18 is equal to F upon 4.1 centimeters. This is 4.1. So 4.1 multiplied by tangent 18 is equal to 1.33, and this is centimeters. So centimeters. Similarly for this one, this is adjacent with the angle, so G. So cos 50 degree is equal to G upon 5.3. So G is equal to 5.3 cos 50 degree is equal to 3.41 meters. For this one, this is sine, because this is opposite and hypotenuse. Sine 5 degree is equal to h upon 23, and h is equal to 2 meter. This is question number 1. 2. The ladder shown have in 6 meter long. So this ladder has 6 meter length, this ladder, and the angle between the ladder and the ground is 70 degree. The ladder and the ground is 70 degree. This is 70 degree. How far from the wall is the foot of the ladder? How far from the wall? The foot of the ladder. So this is the foot of the ladder and this is the wall. So from the foot of the ladder to the wall distance, so from here to here is considered x is the distance. So cos 60 degree, this is adjacent and this is hypotenuse. So cos 70 degree is equal to x upon 6. So x is equal to 6 into cos 70 degree, which is 2.05 meters. So from here to here the distance is 2.05 meter. Simplifying the height of the triangle. So we have to find the height of the triangle using the height of your found in part A to find the area of the triangle. So this is sine 35 degree is equal to h upon 12. So h is equal to 6.88 centimeters. So this height is 6.88 meter. And from part B, so this is the height and this is the base 20. So half 20 centimeter into height is the area, 68.8 centimeters square. So this is the area of the triangle. And question number 4. A ship sails on a bearing of 70 degree. This shape is here. Ship is here with the bearing angle of 70 degree for 250 kilometers. So the distance is this much, is 250 kilometers. How far from north the ship has traveled? This distance has to we have to find this distance. So this is the part 1. And how far find how far east the ship has traveled. So how far east the ship has traveled. So in a part A, this is cos 70 degree and this is 250 and this is y. Find how far north the ship has traveled. So this is y. From this in this direction we have to find this distance, because if it moves, so in the north direction this movement is the part of that movement in the north direction is y. So cos 70 degree is equal to y upon 250. So y is equal to 250 into cos 70 degree and y is equal to 85.5 kilometers. So the part 1 is 85.5 kilometers. And this is the east direction, so this is also parallel to this one. So we can find this by using sine 70 degree x upon 250, sine 70 degree x upon 250, and x is equal to 235. So x is in the distance traveled in the east direction. So this is the distance that is traveled in the east direction. So this direction and this direction is the same. These two lines are parallel and the ship moves in this direction. So in the east direction the traveling is 235 kilometers. Question number 5. The diagram shows a crane. This is a crane. The height of the crane arm is 20 meter. The length of the crane arm, this arm is 20 meters. The crane has operated with the arm anywhere between 15 degree, and this angle could be 15 to 80 degree in the vertical. So this can move from 15 to 80 degree. Calculate the minimum and maximum value of x. So this minimum and maximum value of x, the distance from the crane at which the load can be lowered. So at sine 15 degree, so this is the angle sine 15, and this is the distance which is parallel to this one, this line which is parallel. So this is x, and this is this distance 20 meter, and sine 15 degree is equal to x upon, because this is opposite, so x upon 20. So x is equal to 20 into sine 15, which is 5.18 meters. So this is x value is 5.18 meter for 15 degree. For sine 80 degree, this is x upon 20, and this x is equal to this one is minimum, this is 15 degree, and this is 80 degree. So 80 degree is giving 19.7. So this is 19.7, and for 15 degree, this is just a small degree, 15 degree, it gives x value is 5.18 meters. So this is very, very important. This is simple question. Question number 5. In the next section, we'll discuss 36.7.